Ever wonder how two particles light years apart can communicate faster than the speed of light? Imagine having a friend who can instantly know your thoughts, no matter how far apart you are. Sounds pretty cool, doesn't it? Well, in the world of quantum physics, this isn't just a cool concept, it's reality. Welcome to the concept of quantum entanglement, a phenomenon that left even the great Albert Einstein scratching his head. Quantum entanglement is like a cosmic game of tag, where two particles, no matter how far apart they are, can influence each other's state instantaneously. It's as if they're two best friends who always know what the other is thinking, even if they're on opposite sides of the planet. This seems to violate the speed of light, a universal speed limit set by Einstein himself. But don't worry, we're not breaking any laws here. Sounds like a sci-fi movie, right? Well, welcome to the world of quantum physics. Quantum entanglement, or as Einstein called it, spooky action at a distance. Now, doesn't that sound like a title of a Halloween special? But trust me, it's more fascinating than frightening, although it did give good old Albert a few sleepless nights. Einstein, the man who could bend time and space in his mind, had a bit of a tough time wrapping his head around this one. You see, quantum entanglement seemed to contradict the classical physics he held so dear. It's a bit like finding out that your favorite childhood bedtime story doesn't quite end the way you remembered it. Quantum entanglement is like the mischievous cousin of classical physics, the one who shows up at family reunions and tosses the salad bowl into the air just to see where the croutons land. It's the idea that two particles, no matter how far apart in the universe, can be linked in such a way that the state of one can instantaneously affect the state of the other, hence the spooky action. Let's break it down a bit with a metaphor. Imagine you're flipping a coin. According to classical physics, it's either heads or tails, right? But in the quantum world, that coin is in a state of superposition. It's both heads and tails at the same time until someone looks at it. The act of observation forces it to choose a state. Now, imagine you have two coins, miles apart, both flipping in the air. In the realm of quantum entanglement, the moment one of these coins lands, the other one knows what it should be instantaneously. Spooky, huh? It's as if the universe is playing its own version of the twins paradox. That thought experiment where one twin travels to space and ages slower than the one left on Earth. But in our case, it's not twins, but particles. So it's like the universe's version of the twins paradox, but with particles instead of people. Now, how do these particles get entangled in the first place? Well, the process of quantum entanglement is quite intricate, yet utterly fascinating. It's much like a dance, a quantum tango if you will. Imagine two particles, let's call them Alice and Bob. Alice and Bob meet in a crowded, energetic space, the quantum dance floor. Here, amidst a flurry of other particles, they interact. This interaction, which can be anything from a collision to a shared experience, links them together in a special way. Now, when Alice and Bob separate, they carry with them the memory of their dance, their shared interaction. This memory is their entanglement. It's like they've learned the steps to a complex tango, and no matter how far apart they drift, they remain in tune with each other's movements. So if Alice suddenly decides to change her dance steps, Bob, even if he's at the other end of the universe, immediately adjusts his steps to match. This instantaneous change is what Albert Einstein famously dubbed spooky action at a distance. But here's the twist. Until we observe Alice or Bob, we don't know what dance steps they're performing. They're not just doing the tango. They could be waltzing, jiving, or even breakdancing. It's all a blur of possibilities. However, the moment we take a peek, they snap into one specific dance, and their partner, no matter how far away, does the same. This is the essence of quantum entanglement. Two particles, once entwined, remain connected, mirroring each other's states instantaneously, regardless of the distance between them. It's a delicate balance, a dance of sorts, an intimate tango played out on the cosmic stage. Remember, this isn't just theoretical musing. Experimental evidence has time and again confirmed the reality of this quantum tango. Scientists have entangled particles, separated them by vast distances, and observed the instant mirrored changes. And just like that, our particles are ready to tango across the universe. But what happens when one of our dancing particles changes its state, you might ask? Well, that's where things get really interesting. In the quantum world, the instantaneous change in one particle is mirrored by its entangled partner, no matter the distance between them. It's like they're connected by an invisible, super-fast highway of information. Imagine that. Think about it as the ultimate read receipt. You know, like when you send a text message and the other person reads it, you get a notification? Except in this case, it's a million times more immediate and there's no option to turn it off. It's like they've read your message before you've even hit send. Talk about efficient communication. This phenomenon is so instantaneous that it baffles even the greatest minds in science. It's as if these particles are not just partners in a dance, but two halves of the same whole, forever linked. It's a bond that not even the vast expanse of the universe can break. The particle doesn't send a message to its partner to inform it of the change. It just happens, like magic. But this isn't a magic show. It's quantum mechanics, and the rules are just a little bit different here. This instantaneous information transfer has profound implications for the future of technology. It could revolutionize communication and computing, making them faster and more secure than ever before. We're talking about a future where information can travel at the speed of, well, thought. But don't worry, this doesn't mean that your secrets are going to be spilled across the universe. After all, we're still figuring out how to harness the power of this quantum information superhighway. And as for the particles, well, they're probably too busy dancing to gossip. So, next time you're waiting for that text message to be read, spare a thought for the quantum particles, zipping information across the cosmos faster than the blink of an eye. No need for carrier pigeons in the quantum realm. All right, so we have particles that communicate instantaneously. What's the big deal? You might be wondering. Well, let's dive into the fascinating world of quantum applications. First, let's talk about quantum computing. Traditional computers use bits, which can be either a 0 or a 1. But in quantum computing, we have quantum bits, or qubits, that can be 0, 1, or both at the same time. Sounds like a paradox, right? It's like having your cake and eating it too. This gives quantum computers the potential to process massive amounts of data at speeds that make today's supercomputers look like a tortoise racing a hare. But wait, it gets even better. Quantum entanglement allows for the creation of qubits that are linked, so that the state of one instantly affects the state of the other, no matter the distance. It's like having twins with telepathic abilities, only in this case, it's particles instead of people. Now imagine the possibilities. Quantum computing could revolutionize fields like cryptography, making our online transactions and communications more secure. It could make hacking a thing of the past. Imagine that, a world where your credit card information is as safe as a kitten in a room full of pillows. But quantum applications are not just limited to computing, they could also revolutionize communication. With quantum entanglement, we could potentially have instantaneous communication across vast distances. Say goodbye to lag in your interplanetary video calls. Quantum teleportation is another mind-boggling application. Scientists have already successfully teleported information between photons over short distances. It's not quite beam me up, Scotty, yet, but who knows what the future holds. So the big deal about quantum entanglement is its vast potential to transform our world. From super-fast computers to secure communications, the possibilities are as limitless as the universe itself. And all of this is made possible by those tiny entangled particles. Quantum entanglement, coming soon to a computer near you? Well, that's the big question, and only time will tell. So there you have it, the weird and wonderful world of quantum entanglement. This fascinating theory truly pulls the rug out from under our classical understanding of physics. It's like the universe decided to throw a surprise party and didn't invite Newton or Einstein. We've skated through the icy enigma of the quantum quandary and shivered at the spooky action at a distance. We've danced the quantum tango and sped down the information superhighway. And let's not forget the captivating world of quantum applications, where the potential is as boundless as the universe itself. From quantum computing to teleportation, and even to the creation of uncrackable codes, the applications of quantum entanglement are as vast and varied as the cosmos. It's a realm where the impossible becomes possible, and the improbable, probable. And remember, in the quantum world, distance is but a detail.